Today's lesson is an introduction to matrices. Please be sure to subscribe so that you don't miss out on any future videos. A matrix is an array of numbers, also known as entries or elements, that are arranged in rows and columns. How do we determine the size of a matrix? The size of a matrix is the number of rows and columns it has. The size of a matrix can be written as R times C, where R is equal to the number of rows and C is equal to the number of columns. Let's look at a few examples and determine the size of the following matrices. Matrix A consists of 2 rows, so R is equal to 2. And it consists of 3 columns, so C is equal to 3. Therefore, the size of matrix A is 2 by 3. Let's look at another example. Matrix B consists of 2 rows, so R is equal to 2. And it consists of 2 columns, so C is equal to 2. Matrix B is a 2 by 2 matrix. Let's look at one final example. Matrix C consists of 4 rows, so R is equal to 4, and 2 columns, so C is equal to 2. Therefore, the size of matrix C is 4 by 2. Next, we must determine how we can refer to the entries in a matrix. We're going to use matrix C from the previous example, and we're going to use double subscript notation. C represents the matrix, and I is equal to the row number, and J is equal to the column number. We're going to look at the following 2 examples and determine the entry of matrix C in row 2 and column 2. We're going to see where these 2 intersect, and the value is 6. Next, we're going to look at the entry of matrix C in row 3 and column 1, and we can see that the value is equal to 2. How do we know if matrices are equal? The following 2 properties must be satisfied. Matrices must be the same size, and all entries in a matrix must be equal. Let's look at the following example and determine if matrix A and matrix B are equal. Matrix A consists of 2 rows, so R is equal to 2, and it consists of 2 columns, so C is equal to 2. Therefore, it's a 2 by 2 matrix. Matrix B consists of 2 rows, R is equal to 2, and it consists of 2 columns, so C is equal to 2. And the size of matrix B is 2 by 2. Both matrices are the same size. Next, we must determine if all entries are equal. And in this case, we can see that this value here in matrix A and this value here in matrix B are not equal. Therefore, matrix A and matrix B are not equal. Next, we're going to look at some unique matrices. A row matrix, also known as a row vector, is a matrix that consists of 1 row and 1 or more columns. The R value for a row matrix is always equal to 1. A column vector consists of 1 or more rows and 1 column, and the C value for a column matrix is always equal to 1. A square matrix has the same number of rows and columns, so a 3 by 3 matrix. A scalar matrix is a matrix whose diagonal entries are the same. Diagonal entries are the entries that have the same row and column number. So C11 is equal to 1, C2 2, 2 is also equal to 1, and C3, 3 is also equal to 1. Therefore, we have a scalar matrix. This matrix can also be identified as an identity matrix. It must meet 3 criteria. It must be a square matrix, which it is, 3 by 3. The diagonal entries must be equal to 1, which they are, and all other entries must be 0, which they are. Therefore, this matrix would be considered a scalar and an identity matrix. Thank you for watching. Please like, share, and subscribe.